In this video, we're going to learn about the third transformation, which is a rotation. And as you can see from my beautiful Snapchat filter, a rotation is a turn. So we are going to take a figure or a coordinate and we are going to turn it on the coordinate plane. So here I've taken my Snapchat picture and I have turned it a certain direction. And if you think about turning, or if you look at the clock, right, we can turn left and we can turn right. But there is a specific word that we use, or words, to describe rotations. When we are rotating a figure, we can either rotate clockwise, which we use CW, or counterclockwise. So I have a picture of a clock here, and when you turn to the right, just like the arrows are shown here, that's called clockwise. The way we read a clock is turning to the right, so we say clockwise. If we were to turn to the left, that's called counterclockwise, and we write CCW to stand for counterclockwise. So if I have a triangle and I would like to rotate it, you need to also have a little bit more information. Should I rotate it or turn it clockwise? Or should I rotate it and turn it counterclockwise? So when we have a circle, right, if you were to stand in one place and do a full turn, do you know how many degrees that is? 360 degrees. When we have our starting point, we say it's 0 degrees. And 0 degrees is equal to 360 degrees because if you stand straight at 0 degrees and do one full turn, you are back where you started. So 0 degrees and 360 degrees, they are congruent. It's the same spot. If I were to turn 180 degrees, if I asked you to stand up and turn 180 degrees, which way would you be facing? You would do 1/2 of a turn. You would be facing, if I'm facing the wall, I'm turning to face the other wall. Okay? And 180 degrees clockwise will bring you the same exact spot as if you were to turn 180 degrees counterclockwise. Let me show you let me draw another picture down here. So if I'm here I am, and I turn 180 degrees clockwise, right? Now I'm down here. But if I turn 180 degrees counterclockwise, I'm still in the same spot. So 180 clockwise, 180 counterclockwise, it doesn't matter. It's the same thing. They are congruent turns. That's important to pay attention to because when we talk about 180, sometimes in the textbook they don't differentiate between clockwise and counterclockwise because they're the same. Now let's talk 90 degrees counterclockwise. If a full circle is 180 or 360, right? And I'm only going 90, well, 360 divided by 90 would be 4 turns. So if I go 90 clockwise, 90 more is 180, 90 more is 270, 90 more is back to our starting point at 360. So if I go 90 degrees clockwise, that is the same thing as counterclockwise 270. Because I did 90, 90, 90. It's 270 degrees. Those turns are congruent. Let's change the color. If I turn 90 degrees counterclockwise, that's this way, 90 degrees counterclockwise. Here I am. That is congruent to how many degrees clockwise? 90, 90, and 90 is 270 counterclockwise. Okay? And we're going to review this some more. let's take a look at our first demonstration. Okay, so here I have some points to remember. A full turn is 360 degrees. Now I'm talking about coordinates on a coordinate plane, and we have divided our coordinate plane into 4 parts, 4 quadrants. So 360 divided by 4 means that each quadrant is 90 degrees. Okay, so if I start here and go around, that's 90 degrees. Another 90, here I am down here at 180. Another 90, and then back another 90 to our 360. There's the bell. So take a look at this square that I have put here. I have my first coordinate, which is here. This is what you're going to want to pay attention to, that yellow dot. That is what we are rotating. And notice I've added these arrows. This shows that the y-axis up here is positive. The x-axis to the right is positive. Down here on the y-axis, we know it's negative. And over here on the x-axis, it is negative. Okay? So there are rules for rotation, and there are things that you want to memorize to help make rotations a little bit easier. As I said in class, rotations are a little bit trickier because there's a lot of rules, but I'm going to show you where do these rules come from. So I have my coordinate, my starting point. Remember this yellow dot I told you to pay attention to, and that coordinate is 2, 3. This is the point we are going to rotate. Okay? So I'm going to rotate it first 90 degrees clockwise. Right? I'm going to work with clockwise because we read a clock clockwise, and that's just our go-to. So if I turn 90 degrees clockwise, where should my yellow dot land? It will land, whoopsie, let me erase my little red. Here we go. It will land in quadrant 4. Okay, do you see how my box has turned 90 degrees to the right? Okay, so now my yellow dot is right here, and I'm going to make it red. But look at my x and my y. The x is now pointing down towards the negative, and the y is pointing to the right, which is positive. Okay? I have ultimately switched the places of my x and y, because originally my x was here, and now it's on the y-axis. They kind of flip-flopped. But my y is positive, and now my x down here is negative. So to describe that rule, for 90 degrees clockwise, we take our original coordinate, which is 2, 3, and we flip-flop the x and the y, and we do the opposite for whatever the x is, because now my x was negative down here, because it's facing in the negative direction. So what is this new coordinate in red? It is 3, -2. Notice the difference between this coordinate and our original coordinate. I have flip-flopped the places of x and y, and I have given that 2, the x value, a negative sign. I've done the opposite. Let's try again. I'm going to turn it another 90 degrees, which would be 180. Clockwise, again, 180 doesn't matter, clockwise or counterclockwise. So now my dot, I'm going to make it green. Doesn't really stand out, but that's okay. So my x is still riding along the x-axis, and my y is still riding along the y-axis. Okay? But now my x is pointing to the negative, and my y is pointing to the negative. So they didn't flip-flop. They're just facing the opposite sign. So it was once positive, now it is negative. So the rule for 180 is we take our original coordinate, 2, 3, and we do the opposite. When you see that minus in front of the letters, the x and the y, that means that it's the opposite sign. So the 2 was positive. Guess what my coordinate is down here? -2. My y was +3, but down here, 180, it's now -3. Let's turn it one more time. Oh my goodness. Get rid of here, this dot. Okay, there it is. So let's do this one in blue. Now my final dot in blue is in quadrant 2. I have rotated it 270 degrees clockwise. Look at my x and y axis. My x is riding along the y, and my y is now along my x axis. So my x and y's have flip-flopped. The x is positive and my y is negative. So for 270 degrees, we say that the rule is just like 90 degrees clockwise, 270 clockwise. I'm switching the place of x and y, but I'm doing the opposite for y. Because what is my coordinate in blue? -3, 2. Look back to that original. I flip-flopped x and y, I switched them, but I am doing the opposite for the y value. 90 degrees, we did the opposite for x. 270, we do the opposite for y. I know that was a lot. Let's take a look at an example. In your notes, I have this chart for you. This is going to want to be like where you go to help you with rotations, and I would write it down a million times so you remember. When I go 90 degrees clockwise, my original coordinate, I flip-flop x and y, and I do the opposite for the x. 180, here's my original coordinate. I don't switch them. X stays first, y stays second. I just do the opposite. Okay, that minus sign in front tells me the opposite. So if it's positive, I make it negative. If it's negative, I make it positive. And then 270 clockwise, I have my original coordinate, and I flip-flop them, and I do the opposite for y. Let's do an example using the chart. Let me erase all this so we can see it a little bit better. Okay. If I have point A at 3, -4, I'm going to do a 90 degrees clockwise rotation. So here's clockwise. This is the rule. I flip-flop the 3 and the -4, and I do the opposite for x. So that means my -4 is going to come up front. Oops. Oh my goodness, this pen is going crazy. Okay, I bring my -4 up front, and I do the opposite for x, which would be a -3. So my coordinate is -4, -3 once I've turned it 90 degrees clockwise. Point B, I have the point -2, -1, and a 180 rotation, according to my rule, is just do the opposite signs. So a -2 becomes a +2, and a +1 becomes a -1. Just do the opposite signs. Point C, here I have -9, 0. 270 clockwise. I'm flip-flopping the places and doing the opposite for y. So here's my y value. That's weird. What's the opposite of 0? Well, there's no such thing as -0. So we're just going to leave it as 0 and then put the -9. Okay? You can't put a negative or positive 0. There's no such thing. 0 means the absence of value. So if you have a 0 and you need to do the opposite, you just leave it as 0. Figure 1 is rotated to form figure 2. Describe the rotation. So here's my pre-image, number 1, and I have rotated it to figure 2. So the first question is, should I go clockwise or counterclockwise? Well, if I go clockwise, I go 90, right, to this quadrant, and 90 more. And this is where I land. So that's 180 degrees clockwise. If I do counterclockwise, if I move 90 degrees and another 90, here I am. Do you see how 180 counterclockwise and clockwise are the same? So let's erase this one so as to not confuse us. Okay. So we can say that this trapezoid or quadrilateral was rotated 180 degrees. Now let's just double check to make sure, let's look at our coordinates. What are the coordinates for Q, R, S, and T? So Q is located at 1, 4. Where is Q prime? Down here at -1, -4. Look at the coordinates. I didn't switch them. All I did was do the opposite sign. That's going to be the rule for all of them. R is located at 5, 1. Where's R prime? -5, -1. Again, I just did the opposite sign. S is located at 2, 1. So S prime is -2, -1. T is located at 1, 2. So T prime should be at -1, -2. Here's my negative. Do the angle measures or side lengths change? When I rotate my figure, do the lengths get longer or do the angles get bigger or smaller? No. These two figures are congruent. The next example. I have A, B, and C, and I'm going to rotate it 180 degrees. So take your pen. You could use colored pencils, whatever you want. And look, I have my chart here to help me remember. The rule for 180 is just do the opposite sides. So I'm going to plot and label -1, 2 is A, 2, 6 is B, and 5, 1 is C. Let's connect our dots as neatly as you can. Now I'm going to rotate it 180. So the difference between rotations is you have to write the coordinates first. So I'm doing the opposite. So if it was a -1, 2, it's now +1, -2. B, do the opposite, -2, -6, and C, -5, -1. Let's plot them and see what happens. I have 1, -2, so this is A prime. Make sure you label it correctly. -2, -6, 3, 4, 5, 6 is B prime. And C prime is -5, -1. Connect the dots. And we have two congruent triangles. And you can see I rotated it 180 degrees. This would be 90 down here in quadrant 4. 180 degrees. This is my pre-image, and this is my new image. Next example, I have CAT, triangle CAT, and I'm going to rotate it 90 degrees clockwise. And using my chart, I know that I'm going to flip-flop the places of X and Y and do the opposite for X. So this is where I love the highlighter. I'm doing the opposite for X. So let's highlight which one we have to do the opposite for. The 9, 4, and the 6, I'm doing opposite signs for. So in this example, they'll all become negatives. So let's write them first. Let's make our life a little easier. So if I have to switch them and negate the one in yellow, the X value, this will become a -1 comes up front, -9. For A, -1 comes up front, -4. And T, -7 comes up front, and do the opposite for the 6. Now let's plot and see what it looks like. I have 9, -1. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's C prime. A is 4, -1. And T is 6, 1, 2, 3, 4, 5, 6, -7. 1, 2, 3, 4, 5, 6, 7. Let's connect neatly as you can. Make sure I can see your dots, your coordinates. Now we're going to rotate it. So this is our pre-image, number 1. So now let's do our new image. So -1, -9 would be C prime. -1, -4 would be A prime. And -7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6 would be T prime. And let's connect. This is our new image, and you can see I have rotated my triangle 90 degrees clockwise. It's in the next quadrant. Lastly, sometimes you won't have a graph and you're just going to need to rotate points. So we're going to use our table to fill in this chart. So if I have the coordinate 5, 7, 90 degrees clockwise, remember I flip-flop the places of x and y, and I do the opposite for x. Okay, so I'm going to do the opposite for x. This is x and y. So 90 degrees clockwise would become, bring the 7 up front and do the opposite for x. Same thing here. Bring the 3 up front, flip-flop them, and do the opposite for that -4, which would become positive. Do the opposite for -2 and bring that -1 up front. 180 degrees, all we're doing is the opposite sign. So +5, +7 becomes -5, -7. -4, +3 becomes +4, -3, opposite signs. -2, -1 becomes +2, +1. And lastly, 90 degrees counterclockwise. We flip-flop x and y, and we do the opposite sign for y. So let me erase this here. Now I'm doing the opposite for y. So these numbers I'm going to change, do the opposite. So this would become -7, 5. Do the opposite of the 3, so that would be -3, and just tack on that -4. And do the opposite of -1, which is +1, and leave the -2. Let's try some examples.